Okay, so this is going to be chapter 22, the proportions and ratios chapter from my book, Overcoming Digital SAT Math Prep. So, also, before I get started, I always forget this, or almost always forget this. Make sure if you have a copy of this, for the best results, attempt the problems on your own first, timing yourself 1 minute per question, and then attempt to do the corrections on your own before coming back to this video as a reference for like explanations on stuff that you can't figure out on your own. That's how you're going to do the best on this exam. Also, I'm going to link in the description of each of the videos in this playlist. Over time, I'm going to link different like videos I do that are related to whatever chapter that video is on that you might find helpful to like see as a lesson prior to doing the problems, or just like extra like challenge problems, stuff like that. So just keep an eye out for that. Okay, so let's go to number 1. So it says a cube's volume increased by 33.1% when its edge length was increased by p%. What is the value of p? So let's think of volume of a cube. The volume of a cube is always equal to s cubed. That's an s. Sometimes people think I wrote a 5. It's an s. The side length cubed, or like the edge length cubed. So let's say that this is the original volume. So this will be like my OG situation. And then I'm going to talk about a new situation. I have my new volume, which it says is increased by 33.1% when its edge length was increased by p%. So the new volume, if we're thinking about it increasing 33.1%, remember, if you have 100% of something, you have all of it. So we have to do 100 plus 33.1 to get the total percent we're talking about. So we're talking about 133.1% of the original volume. So the new volume is equal to 133.1. That's it as a percent. If I want to turn it into a decimal so I can multiply by it, it's going to be 1.331, because I moved the decimal 2 to the left, times the original volume. We can also say, for the part that we just read about, like the edge length increasing by p%, we can say, oh, I know volume of a cube is equal to the side length cubed, and this new side length is going to be increased by that p%. So that means that this new side length is going to be the original side length, s. Whoops. Oh, let me rewrite that. That's terrible. The original side length, s, plus, and then p over 100 times the original side length, because it's increasing by that many percent. If we wrote the percent as a fraction, it would be the p% out of 100. So it's going to increase by that much, and this whole entire thing represents the new increased side length or edge length. So I have to cube it all to get the new volume. So now I have that these two situations are both equal to this new volume right there. I also know that I can replace the original volume with s cubed. So I can say this is just s cubed. And now I can set these situations equal to each other. Now, that's how most people see this problem, and you can totally solve it like that and set these equal to each other, but I'm going to show you a quicker and what I think is like a better method of solving it, which is how I see it. So let's do that. So I can think of, I'll just name it x. X is the amount that I'm multiplying the original side length by, because it's going to increase by that many times, or that amount. So I'm going to say that I have some factor x that it's that the original side length s is being multiplied to give me my new side length. And then that's going to be all cubed. So this is the new side length cubed, is what I'm saying right there, is what x times s is. X times s is the new side length. I want to be very clear about that. So now I could set these equal, and the reason this is easier is because then I'll have an s cubed on each side that I can just automatically cancel out a lot more easily than having to like combine fractions and stuff like that. So this is what I have. Remember, these are both the s, meaning the original side length is the s part, And then you see I can just cross out this and this on each side because they cancel out. You can also think of it as like dividing by s cubed. Either way, it's going to cancel out to 1. So now I just have 1.331 is equal to x cubed. So now all I have to do to get x by itself is the opposite of cubing, which is cube rooting. So I just have to cube root 1.311 to find out what x is. And when I do that in my calculator, I'm going to get that x is equal to 1.1. So that means that what we're multiplying the original side length by when it's increasing by the p% is 1.1. Well, what is 1.1 as a percent? 1.1, if I move the decimal over 2 to the right, I'm going to have that this is really 110% of the original side length, meaning I have 100% of the side length and I increase it by 10%. So it would just be 10 is the value p, that's the percent it's increasing by. Okay, so now let's go to number 2. So for this one, we want to find the mass of the object in grams, and this is just a direct proportion. So with these, I like to say the trick is to match units on top and match units on bottom and put a matching relationship on each side. So what I mean by that is like they give us this relationship, 1 gram is equal to 1,000 milligrams. So I'm going to say that's one relationship that I can put on one side, 1 gram for every 1,000 milligrams. And then on the other side, I'll have some other relationship, but I have to make sure that my units match on top. So this has to be the grams part of that other relationship. And then on bottom, I have to have the milligrams part because it has to match on bottom as well of that relationship. So it says that we're finding the mass of an object in grams. So we want to find the grams. So that's the missing part, which we'll just label with X. And it's related to the 5,000 milligrams. So we want to find x when we have 5,000 milligrams. So now I've set up my direct proportion. Now I just have to cross multiply, meaning I do 5,000 times 1. I think some of your teachers call it like the butterfly method or something like that also. You might know it as that. And then I just call it cross multiplying, and then 1,000 times x, so it equals the other thing when we cross multiply. Then you just have to divide by 1,000 on each side to get x completely by itself. And then you're going to get that x is equal to 5. So it would just be C. Okay, so now let's go to number 3. A certain material is so thin that a sheet weighing 2 ounces can cover up to 3 farm fields. So 2 ounces, 2 ounces, I'm just going to underline it, to 3 farm fields. If a farm has an area of approximately 1 3/4 acres, about how many acres could 36 ounces of this material cover? Okay, so first let's figure out what 3 farms is in terms of acres. So I'm going to say, okay, 1 farm, I'm setting up a direct proportion, kind of like the previous problem. 1 farm is related to 1 3/4 acres, and if I turn that into a mixed, not a mixed number, an improper fraction, I would do that by doing 4 times 1 is 4, plus 3 would be 7, keep the bottom number, so 7/4. So 1 farm is equal to 7/4 acres, and then that's one relationship. On the other side, I'm going to have 3 farms, and then I'm solving for how many acres that is equal to. So I'm going to cross multiply. So I'm going to do 1 times x is obviously just x. And then 3 times 7/4, that's the same thing as 3 over 1 times 7/4. So that's just going to be 21 over 4. So that's what x is. That's how many acres we're talking about. But remember, we're not done. So for that's that many acres in reference to 3 farms. So we also know that this many acres is related to 2 ounces because the 3 farms was related to 2 ounces. So now what I'm going to do is I'm going to set up a proportion with acres and ounces as my units to find out how many acres is related to 36 ounces. So let's do that. So I'm going to say x acres is to 36 ounces as 21/4 acres. Hopefully I'm spelling that right. I think I am. Acres, yeah. For some reason it felt wrong. Is to 2 ounces. So now I'm going to cross multiply that. And this is a different x, by the way. It's not the x I was referring to before. I just set up another equation. In fact, I'll even use y just to not confuse people instead. So y acres is to 36 ounces as 21/4 acres is to 2 ounces. Now I'm going to cross multiply and solve for y. So 2 times y is just 2y. And then now I have 36/1 times, so let me show you this because I want you to see me canceling out and not have questions. So now I have 36/1 times 21/4. Now 4 goes into 4 one time. It goes into 36 9 different times. So now what I have is 2y is equal to whatever 9 times 21 is, and that's going to be 189. So now I'm going to divide by 2. So in my calculator, I'm going to put 189/2. And when I do that, that's going to be closest. It's not exactly 95, but it's closest to 95. So it's going to be B. Okay, pause to read number 4 if you haven't already. For number 4, again, we're going to set up a direct proportion. Remember just that trick about the units and everything to set it all up. So like a relationship on one side, a relationship on the other, with the units matching on top and units matching on bottom. So it's saying that we want to find how many hours per week the student should study, he or she should study, if they want to increase their score by 135 points. So the relationship here is the X hours that they're going to be studying per week over, and then it's going to be the increasing their score by 135 points, like their score going up by 135 points. And then on the other side, I'm going to just make sure that I have hours on top and points that they're increasing on bottom. So it's going to be 3 hours is related to a 90-point increase. So now I'm going to cross multiply, and that's going to give me 90x is equal to 135 times 3. So then all I have to do is, in my calculator, I'm going to put 135 times 3 divided by 90 to figure out my answer. And when I do that, I get 4.5 as my answer, D. Okay, pause to read number 5 if you haven't already. So let's talk about our relationships here. We have 1 pound of soap equals a cost of $3, and we want to know how many X amount of dollars. This, I'll just put like a dollar sign there so I know it's in dollars. How many dollars will C pounds? I know that doesn't really need an S, it's just like an OCD thing. Okay, so we're gonna ignore that. Is equal to C pounds of soap. So let's set this up. So when I set it up, remember I have matching units on top, matching units on bottom. So this is what it looks like. Now I'm gonna cross multiply. So I'm gonna cross multiply. 1 times X is X, 3 times C is just 3C, or C times 3, whatever you wanna do. So I get that X is equal to 3C, so the correct answer should be A. Okay, pause to read number 6 if you haven't already. So let's rewrite this ratio of, remember it's going to be milk to vanilla syrup to coffee. So let's rewrite this as 2x, 3x, 4x. Because remember, this is kind of like, think of it as a simplified version of a fraction. Like when you have these types of ratios like this, they have to be multiplied by some factor, and they're just like in their simplest form right over here. We've divided by that greatest common factor to get this ratio, basically. So if the barista uses 6 ounces of coffee, so coffee is represented by 4x, so we can say that 4x is equal to 6 ounces of coffee. And then we want to find what is the total volume of the drink in ounces. So then I of the drink in ounces. So then I can use what I find for X to plug into X here, here, and here, add all those up, and I get the total volume. So when I divide by 4, I get 6/4, which if I simplify by dividing by 2 on top and bottom is just 3/2. So X is 3/2. So now I'm going to plug that in for X in each of those. So that's all I'm doing here. I'm just plugging it into each of these and adding it all up to get the total volume. And when you do all of that, you're going to get 13.5, B as your answer. Okay, pause to read number 7 if you haven't already. So I've written the general formulas for the volume of the sphere and volume of a cylinder, and from this point forward, I'm also going to say Vs could be representing the volume of the sphere, and Vc could be the volume of the cylinder. So now it's important to remember in these types of problems, the radius for each of these could be different, but this specific problem is telling you that the radius is the same, so we can just treat these r's as the same r. But it could be different in another problem. Just be aware of that. So we want to know, for what value of r will the volume of the sphere be thrice, meaning 3 times the volume of the cylinder. So we want the volume of the sphere to equal 3 times the volume of the cylinder. Remember, volume of a sphere can be represented by this equation right there. Volume of a cylinder can also be represented by this equation right there. So I'm going to plug those in. So now I've done that. And I'm also going to plug in what the height of the cylinder is. For height, instead of saying h, I know that the height is 12. So I can say just times 12 right there instead. I see a pi on each side, so I can cancel those out. And then I see an r cubed and an r squared. So if I divide by r squared on each side, this cancels out to 1, and then I can just get rid of this because I'm just left with one factor of r, one group of r, however you want to think about that. So now I can say I have 4/3 r is equal to, 3 times 12 is going to be 36. So now I just need to solve for r, get r by itself by dividing by 4/3 on each side, which, remember, if you're dividing by a fraction, keep, change, flip, says that it's the same thing as multiplying by its reciprocal. So this is the same thing as having 36/1 times 3/4. 4 goes into 4 one time, it goes into 36 9 times, and then 9 times 3 is 27, 1 times 1 is 1, so 27/1 is just 27. So that would be our answer. Okay, so now pause to read number 8 if you haven't already. So let's say we have 2 objects, object A and object B. I'm going to call object A our reference object. So it's like the object we are referring to when we're saying if one object's velocity is 3 times another, the another that we're referring to as the reference is going to be A. So I'm just going to say that the kinetic energy for A is equal to 1/2 of the mass times the volume squared, velocity squared. And this M and this V are going to be just for the A object, because remember, we're going to have a different mass and volume over here, so I just want to specify that. So for object B, we know that its velocity is 3 times the other's velocity. So object B's velocity is going to be equal to 3 times our reference, so 3 times the velocity for A. And then we have that it's 2 times another's mass. So the mass specific to object B is going to be equal to 2 times the mass for A. Its kinetic energy is how many times greater than that of the other object. So we want to figure out how many times greater the kinetic energy is for B, essentially. So let's write out this scenario using the general equation. Remember, this is the general equation. We just have to be specific about what type of kinetic energy, if it's A or B's kinetic energy. Same thing for the mass. The mass is the mass for B, so it has to be equal to 2m, 2 of the original references mass for object A. So I'm going to say the kinetic energy for B, because kinetic energy is always equal to 1/2 mass. So the mass for B I can represent by 2m, and then times the velocity, which I can represent with 3v squared. So I have two equations. I have an equation that gives me the kinetic energy for A and an equation that gives me the kinetic energy for B. Now remember, I want to find out how many times I have to multiply this kinetic energy to get to this kinetic energy for B. So I'm going to see, can I rewrite this equation right here to look more like the situation I have for the kinetic energy for object A? And I can. I can say the kinetic energy for B is equal to, and then if I wanted to just have it be 1/2 mv squared like I have over here, I could say, oh, well, I can factor out that 2. I can take out that 2 and multiply by it like kind of just farther away in a different place. And then I can also say, oh, 3 squared is what this would turn into. So that's 9 times v squared when I square this. 3v times 3v is 9v squared. So I can take out that 9 as well. So I can say I have 2 and a 9 that I'm taking out, that I'm factoring out. And then they're being multiplied by what's left over, which would be 1/2 of mv squared. What do you know? That's exactly what we have for the kinetic energy of A. So I could replace that with the kinetic energy of A, like Ka, and then I have 2 times 9 times the kinetic energy of A equals the kinetic energy of B, and then that's just going to be 2 times 9 is 18, so it's 18 times the kinetic energy of A. So it would be T. Okay, pause to read number 9 if you haven't already. But it basically is referring to the same general formula, like we're talking about kinetic energy. It's just like a different sort of scenario. So that's all we have to keep in mind. That's why I rewrote it there, just so I don't have to like keep scrolling up and down. Okay, so basically I've just written the information kind of like in a more equation-y way. So B is going to be like what we're referring to our reference. So they have the same mass, so that's why m is the same for each of them. I'm plugging in the same m into this general formula. Now for each of their velocities, I'm going to call, since B is going to be my reference, I'm going to say that V is representing the velocity for object B, and I'm going to say that x is the fraction I'm multiplying V by, like the velocity of B by gets multiplied by this fractional amount x to get me the velocity I need for A that I would be plugging in. And then the kinetic energy for A is equal to 1/16 times the kinetic energy for B. So now I have everything that I would plug into this general formula up here. So I plugged all the information into the general formula for each of these, into these two situations for A and B. And I also know the kinetic energy for A is equal to 1/16 of the kinetic energy for B. So now I have actually two equations that are equal to K of A. So these both equal K of A, so they technically both equal each other as well. So I'm going to set that up in an equation format. And that's what that would look like. Now remember, I want to solve for x. Oops, I actually just realized I wrote that wrong. I forgot to put the 2 on the outside. The 2 should be on the outside. Sorry. Okay, so now we're solving for x, now that I've corrected that. And I'm going to say, okay, what can I cancel out to make my life easier? So 1/2 and 1/2 can cancel out. You're free to like multiply stuff and then like simplify later if you want. It's just, I'm trying to make my life easy. I see an m on this side, so I can cancel out an m on this side. And then I'm going to do what xv squared is. So xv squared means xv times xv, which would end up being x squared v squared. So now I have that that's equal to 1/16 times v squared. So now I can cross out these v squareds right there. So now I just have x squared is equal to 1/16. Well, what fraction squared gives me 1/16? That would just be 1/4. So the answer is C. Okay, pause to read if you haven't already. So For the purposes of these exams, I would say that it's always easiest to think of ratios as just like another annoying way to write fractions. Like, think of the two dots in a ratio as like a fraction bar, where like this is your numerator and this is your denominator. Because you could treat them the same way when solving. So like if I'm saying there's a ratio of boys to girls in the classroom that's 3 to 5, I could say that there's 3 boys for every 5 girls in the classroom. And I'm going to set up a direct proportion. And I know that there's 25 girls in this classroom that I'm solving for some mystery number of boys, which I'll call X boys. So you see, I've done a direct proportion. I've done a relationship on each side and set up my same units on top, same units on bottom. Now I'm going to cross multiply. So 3 times 25 is going to be 75. 5 times X is going to be 5X. Now I'm going to divide by 5 on each side to get X completely by itself. And when I do that, I'm going to get that X is equal to 15. So there's 15 boys, A. Okay, pause to read if you haven't already. So this is an inversely proportional relationship. So you have to remember this formula right here. Oh, what did I just write? That Y is equal to K over X is what I meant to write. This is what you should picture automatically as the formula for when they're talking about inversely proportional. Now, they're telling you Y is equal to 7. So I'm going to plug in a 7 for my Y. I don't know what K is. And I'm going to plug in when Y is 7, X is 3. So now I'm going to plug in a 3 there for X. Now I can figure out what K is because I'm just going to multiply each side by 3 to get that K is equal to 21. So now I can plug that in for K and I have an equation that works for multiple like X's and Y's. So like if they give me a certain value for X or a certain value for Y, I can find the other variable, what it's equal to with this equation. So it's asking me to find the value of Y when X is equal to 7. So I'm finding Y when my X is 7. So that just means Y has to be equal to 3. A. Okay, pause to read if you haven't already. So she's making a sugar recipe. Again, think of ratios as like fractions. So sugar, so there's 2 sugar to 7 milk. And the recipe requires 14 cups of milk. So we want 14 cups milk for some mystery cups of sugar that we need. So we have these two relationships, which we can set equal to each other. So let's do that, set up a direct proportion. So I set up my proportion, and now I'm going to cross multiply 2 times 14, which is going to give me 28, and then 7 times X is 7X. So if I just solve for X, by dividing by 7, I get that X is equal to 4. So it would be A, 4 cups of sugar. Okay, so we're using this scatter plot for number 13 and 14. So pause to read if you haven't already. Okay, so if we want to find the best approximation of the ratio of sloths in 1979 to sloths in 2018, it would be this number to this number as a ratio. Now remember, it's saying approximately. So we'll say that this is about 5,000 if we round up, and that this is about 61,000 right over there if we round up there as well. And you're going to get like it's a 1 to like 12.2 ratio, so that's going to be closest to A. Now that I think about it, like I was thinking in terms of the paper SAT, you have a calculator, so who cares about rounding? What I would do actually is just treat this like a fraction, because remember I said like ratios, just treat them like fractions for this exam. See what 4,700 over 60,505 equals, and then turn each of these into fractions to see what's closest. Because like this is 1 over 13, this would be 1 over 14, this would be 1 over 16, this would be 1 over 20. So see what gets you the closest to this. So this guy is going to be 6.776795, yada, yada, yada. So let's see what gets us closest to that as a strategy. And I just realized I put the decimal in the wrong place. I don't know what's wrong with me today. Sorry. It's supposed to be there. It's 0.0776. Okay, so now let's do it for, let me put this camera down really quick, each of these. So when you do the 1 divided by 13 in your calculator, you're going to get 0.076923, yada, yada, yada. So now let's do the 1 over 14. I mean, that's like pretty close right there, but we'll see. So when you do that, you're going to get 0.07142, yada, yada, yada. So like you could keep going if you want to get the exact values to like prove to yourself that one's closest, but as you're seeing, when you increase the denominator, like this value is going to be going down, right? So you're actually getting farther away as you increase the denominator from this value that you want. So it's definitely going to be A. So there's different ways that you could go about it. That would probably be easiest, I would think, because it's just really quick with a calculator to do. And then you would see the denominators are increasing, hopefully, or you could just do it individually like I showed you for each of them. So now we're going to find what's the closest slope for the line of best fit in the scatter plot shown over here. So let's do that. So really quick, first of all, obviously it's a positive slope because it's increasing from left to right. So if you were like stressed for time on this exam, you could cross out A because it's a negative slope. You know it's definitely not that. And then you would just be picking between B, C, and D based off of what you get up here. So I would just pick like 2 easy values. Like, for instance, it's real easy to say like it crosses the y-axis right here. So like you could say that you have the point 0, 10,000 as a point that you're going to use. So 0, 10,000, one of the points for your slope. And then I would look for another like pretty easy point for your slope to like determine what it is. So let's see. I would say this one's pretty easy. Like it's pretty close. It's not exactly like if you look really, really close, it's like a little bit above exactly like at the corner, but it's pretty close. I would say like that's an easy one to do, like 5, about 15,000. So now you have 2 points. You could just do slope formula. So subtract the y's. So it'd be 15,000. You could do it the other way too. You could do 10,000 minus 15,000. I'm just choosing to start with this one. 15,000 minus 10,000 over, then you have to start with 5 minus 0. So that's just going to end up being 5,000 divided by 5, which is approximately 1,000. So let's go and look at our answer choices again to see what's closest to that. And that would just be D. That's the one that's closest to 1,000. The others are way off, so it definitely has to be D. Okay, so there's some situations that they just kind of expect you to know sometimes are inversely proportional. And one of those situations is like with a seesaw. So you kind of just have to think like when I see a seesaw or gravitational pull, I should be thinking of inversely proportional. I should be thinking of this formula. Whoops. Oh my goodness. I should be thinking of this formula right here. The y is equal to k over x. So I'm going to use the first set of information to find out what k is, and then with the question portion, I'm going to solve it based off the equation I get after I find out what k is. It's hard. It's easier to see. So give me a second. So the boy weighing 70 pounds sits 2 feet from the middle of the seesaw. So let's say that this is going to be feet. You always have to keep the units consistent for like what x and y are that are inversely proportional. And then this is going to be pounds. So I'm going to say 70 pounds is equal to k over 2, because that's the 2 feet. So then k is equal to 140. So now I'm going to say, okay, now the girl is going to weigh 40 pounds. So it's going to be y is 40. I know what k is. K is 140. And it's going to be over the x amount of feet that she's going to be sitting. From the middle or something. Yeah, from the middle. So now what I'm going to do is I'm going to solve for x. So I'm going to multiply by x on each side. So that's going to give me 40x is equal to 140. And then I'm going to divide by 40 on each side to get x is equal to 140 over 40. The zeros right there cancel out. So it's just 14 over 4. So then I could turn that into a mixed number. And that's going to go in 3 times, and then there's 2 fourths left over, so it's 3 1/2. So that would be B. Okay, so pause to read number 16 if you haven't already. So, you have to think logically about this one. So if there are more kids going on the island, then there's going to be like less days of food, right? So those are examples. That's an example of an inversely proportional relationship. So again, we're thinking of y is equal to k over x. So I'm going to say that this is, you could do it the other way. Like you could say x is kids and y is days as long as you're consistent. I'm just choosing to do it this way. So I'm going to say y is kids and x is days. So they have enough food to last the 10 kids for 8 days. So 10 kids, 8 days, multiply each side by 8 to get k by itself, so it's k is equal to 80. So now instead of k, I'm going to put 80 up there to have an equation. So I'm going to have y is equal to 80 over x. And then I'm going to say if 6 more kids get deserted on this island, how many fewer days will the food last? So 6 more kids means that we have 10 plus that 6 more, so that means we're going to have 16 kids. So 16 is y, because that's in kids as the unit, and it's going to be 80 over x amount of days, so x amount of days that the food will last. Multiply each side by x, I get 16x is equal to 80. Divide by 16 on each side, I get x is equal to 5. So they will have 5 days of food to last, but be careful because the question is asking how many fewer days the food will last. It's going to last 8 days at first, then when you add the kids, it is going to last 5 days, so that's 3 days fewer. So it would be D. Okay, so now pause to read number 17 if you haven't already. This is going to be a directly proportional relationship. So if I set it up, this is what I get. Same units on top, same units on bottom. I forgot to write HF for hair follicles. Follicles? I think that's how you say it. And then I'm going to cross multiply and solve for x. So I'm going to get 2,250 times 1 is just 2,250 is equal to 1,500 times x. So now I just need to divide by 1,500 on each side to get x completely by itself. And I'll have my answer. And the answer is 1.5, so that would be D. Okay, pause to read number 18 if you haven't already. So we're going to say S stickers is related to D dollars, right? So that's going to be our stickers. Oops. And this is in dollars. And we want to know how many stickers can be bought for C dollars. So our other relationship is going to be the X amount of stickers that we want to buy. So same units, stickers. And that's going to be related to C dollars. So let's set up a direct proportion and then just solve for X. So I'm going to have S is to D as X is to C. Cross multiply, I get SC is equal to XD. Divide by D on each side to get X by itself. And that's going to be SC over D is equal to X. So that's just answer choice D. What is the ratio of this many feet, or this many inches, or sorry, this many feet, this many inches? So it's 3 feet, 6 inches to 1 yard. And then we see the relationships down here. So first of all, let's make this into one consistent unit. So I'm going to turn this into just inches. So I know 1 foot is equal to 12 inches. So if I have 3 feet and 6 inches, 3 times 12 is 36, plus 6 would be 42 inches. So 42 inches to 1 yard. And then I know that 1 yard is the same thing as 36 inches. So now I'm going to put this as 36 inches. So now I have the same exact unit over the same exact unit, so I can form a ratio. So this, if I remove the fraction bar and just put like the dots for the ratio, would look like this. I like to first simplify it before I turn it into the ratio, but you could do it either way. So I'm going to simplify by saying, okay, well, 6 goes into each of these. So I could say 42 divided by 6 is 7, and then 36 divided by 6 is 6, so that's 7 to 6 as my ratio, which would be B. Okay, pause to read number 20 if you haven't already. So if they won 32 debates and there were 56 total debates, that means that the number that they lost would be the difference between 56 and 32. So 56 minus 32 is going to be 24. So there were 24 that they lost, 24 debates lost. We want to know the ratio of debates won to lost. So the ones that they won to the ones that they lost. So it would be 32 for the wins to the 24 losses. Each of those can be divided by 8. So divide by 8 on top, you get 4. Divide by 8 on bottom, you get 3. So 4/3 is our answer. B. Okay, read number 21. Pause and read number 21 if you haven't already. So we want to know the fuel efficiency in miles per gallon. So we just need miles per gallon. So 420 is miles, and it's going to be per 7 gallons. That's all you have to do. And then you have your units in miles per gallon. So it's just going to be 7 goes into 420, 60 times. So it's going to be 60 miles per gallon. D. Okay, for number 22, we're going to cross multiply. So 5 times 3x is 15x. And then 7 times x plus 2. So I'm going to distribute the 7 to each of my terms inside the parentheses. So I'm going to have 15x is equal to 7 times x is 7x. 7 times 2 is 14. Now I'm going to subtract 7x on each side to get 8x is equal to 14. Then I'm going to divide by 8 on each side to get x by itself. And when I do that, when I do 14 divided by 8, I get 1.75, which is just C. For number 23, it's especially helpful to think of the little dots, like the ratio dots, as fraction bars. So this is saying 5 over x is equal to 20 over 12. Now just cross multiply and solve for x. So 12 times 5 is going to be 60, and then 20 times x is just 20x. Divide by 20 on each side to get x by itself, and you get that x equals 3. So that would be A. Pause to read 24 if you haven't already. Okay, so let's label this rectangle. So the ratio of the side lengths is going to be 3x to 4x. So we're going to have 4x for the longer side and 3x for the shorter side. And then x is just that greatest common factor that they're dividing by to get that ratio. And the perimeter is going to be 28 units. So perimeter is when you add up all the side lengths. So if I do, if I add up 4x plus 4x plus 3x plus 3x, I'm going to get, that's going to be 14x. And that's going to equal 28 units for the perimeter. Well, I can divide by 14 on each side to get x by itself, and I get x is equal to 2. Now, I want to know the length of the longer side. The longer side is equal to 4x. So 4 times x, or 4 times 2, is going to give me 8. So that's my answer. Okay, now for number 25, pause to read if you haven't already. So if I want the ratio of waffle cones to total ice cream cones, waffle cones would be 5. And the total number of ice cream cones would be 5 plus 3 plus 2, which is just going to be 10. So 5 to 10, C. Okay, pause to read number 26 if you haven't already. So we're going to set up a direct proportion, so let's do that. So this is what that would look like. Now you might notice, oh, I have something squared. It's a little bit different than what we're used to. That's because, look at the question, it's the best estimate for the area in square miles. So I'm finding square miles. So this relationship is just in regular miles and regular yards. If I want square yards and square miles, I need to square each of those numbers in the relationship and their respective units. So that's why I'm squaring right there. 1 squared is just 1, so I just wrote a 1. So now I'm going to cross multiply and solve for x. So this is what I get when I cross multiply. So it's this number squared times x is equal to that. Now, if I end up squaring that number, I get this value right there. So I have that value times x is equal to this number right over here. So now I just have to divide by the 3,097,600 on each side to get x by itself. And when I do that, I get x is equal to 7.0225, yada, yada, yada. And remember, it's the best estimate, so that's going to be B, that's closest to B.